hello. So, wait, hold on. Okay, hello. So today in this video, we are going over what is the solution and how does it impact systems, right? So go ahead and title this in your notes, Unit 3.43 in this title. And our objective for today in this video is that by the end, you should be able to solve a system of equations by finding the solutions algebraically. Okay, now in class, what we ended up doing is we were able to find solutions of a systems of equations. We've seen before with a linear and a linear equation. They intersect at one point, and we can see that on a graph. And in class, we practice seeing a linear and a quadratic, and they possibly could be intersecting between 2 points. And those would be the solutions for that particular system. Now, in class, it was more focused on graphing. We are going to move into the direction of solving algebraically, okay? Now, the vocabulary that will be used in this video would be systems of equations, linear equations, solution point, solution, and quadratic. Okay, so in this example here, it says systems of equations, linear and quadratics. So right here you would have, this is a trinomial, right? And it's also a quadratic equation. And here we can see that this is a linear equation because it has only one x term and it's raised to the first degree. This particular example, I'm not going to go over in this video. Instead, I went over this exact example from your homework over the break. So if you wanted to take a look at that, you can click this link here and kind of refresh your memory on how to substitute x plus 4 into here, which is what I ended up doing in my first step right here in this video. So if you're just like, I need to review that one more time, take a moment to do that. I linked the YouTube video so that way you can go ahead and kind of watch that on your own. But in this video, I'm going to show a different type of system of equations that involves, yes, a linear and a quadratic, but a little bit more complex. So think of this as like, this one isn't as complex. It can be depending on where you're at, but we're going to go into a little bit more complicated problems in this video. So again, example 1, click this link if you want to figure out how to do that. Otherwise, we're going to move on to this example and example number 2. So right here we have a system. We have x plus y equals -2. And then we have y minus x squared equals -4. Now, before you all had, or before, like for instance, in this example, the variable was already isolated, and we could easily just substitute x plus 4, like I did right here, x plus 4 into y. And then you can go ahead and combine like terms and solve for x. This is not the case, right? So the first step when we're working with a system of equations, and we have a linear function or equation and a quadratic equation, we want to isolate one of the variables, okay? So we're going to go ahead and do that. So step 1 is to isolate one variable. And you get to choose. You get to choose whether or not you want that to be the x variable or the y variable. My strategy as well, you could use, when we're solving algebraically, let's see. When solving algebraically, you have essentially 2 options, right? The first option is for you to solve with substitution. You could do that. Or your second strategy could be using elimination. Okay, those are 2 things that will not, they both still work. Okay, this doesn't just happen with linear equations. Okay, it can happen with a linear and quadratic. So these are things that will not change, and you will always have them as your tools and your strategy when solving algebraically. Okay, and that's what you're going to see a lot next class. I'm going to do in this example, I'm going to use the first strategy. I'm going to use substitution to show you all how to do this. Okay, so what I'm going to do is here, go ahead and write these two equations. This is equation 1 and equation 2. Right, and our first step is to isolate one of the variables. Well, I'm going to be a little bit more. It doesn't matter necessarily which equation you select. I'm going to pick the second one, and I'm going to isolate y. Okay, so my first step. So this would be step 1. So that would be here, and I'm going to isolate my y variable. So I'm going to add x squared on both sides. And then y, these will cancel, equals x squared minus 4. Okay, so that is what my y variable is equal to. And so my second step is going to be to substitute isolated variable into into the other equation, depending on what you labeled second, into other equation. In this case, it would be equation 1. So that's what I'm going to do here. So essentially, this x squared minus 4 is going to be substituted into my first equation, which is x plus y equals negative 2. So I'm going to substitute that in right here. So I'm going to go ahead and do that. We have x plus, and then this y is now x squared minus 4 equals negative 2. Right, so I just substituted this expression in for y, and we can go ahead and see if we can combine any like terms. Well, x plus x squared minus 4 can't be combined, nothing at this time, so I'm just going to rearrange these where I have the x squared as my first term. So I have x squared plus x minus 4. I'm like, oh, okay, well, I've seen this before. To find x, I'm going to have to set one side of the equal sign equal to 0, and so I'm going to add 2 on both sides, and I get 0 here. We'll get x squared plus x minus 2. And then we're like, oh, okay, I can be a strong problem solver. I can go ahead and factor this, and this is where you would factor. This one's nice. It's a leading coefficient's 1. It's a trinomial. We can do this one in our heads. Okay, 2 times 1 gives me 2, but we have to think about what our signs, which one will give us negative 2, but add to give us positive 1. So then we'll say plus 2 and minus 1. And then here we can realize we can set each of the factors equal to 0. And when we do that, we'll get x is equal to 1 and x is equal to negative 2. Okay, equal to negative 2. See that a little better. Okay, so we are not done, right? So once we substitute isolated variable into other equation, right here, I can call this step 3, would be to solve for variable. So one of your variables we'll end up finding, which in this case, we found two answers for our x values. And then our final step, step 4, is to find missing variable. Okay, so then in this case, we're going to find the y variable. And we can select either equation to do this. I'm going to use, let's see, I'm going to use this second one, but in this form. So essentially, I'm going to use this y minus x squared equals negative 4. Well, we already did this work, and we already isolated y. So I'm going to use this equation for substituting in my x values to find y. So here I'm going to set this up 2 times. Okay, and I want to see what will happen. What is my y value when x is equal to 1 and also when x is equal to -2? Okay, so here we can go ahead and say y is equal to 1. We're going to substitute 1, and then we'll get y is equal to 1 minus 4, and y will equal -3. Okay, so then we found this answer here, and then here we can go ahead and substitute the same process, and y will equal 4 minus 4, y will equal 0. Okay, so essentially all we're saying is when x is 1, y is -3. And when x is -2, y is 0. Okay, and then all this means is this is our solution. These are our solutions to this linear and quadratic system of equations. So we have essentially two solutions. Okay, sweet. All right, so we're going to use the same process for a little bit more complicated problem that you'll see in class next time. Okay. All right, so this is example 3. So we have 2x plus y equals 1, x squared plus y squared equals 10. Okay, so this one looks a little bit different, and the reason why it does look like that is because this right here, x squared plus y squared equals 10, this is actually the equation for a circle. So you've seen in class a little bit, there was one problem with the circle and a line going through it. So basically, systems of equations, this opens up a whole new world of different types of equations, including circles. So you won't go into circles as much in this course as you will in pre-calc, but you'll at least get an idea of how to find a solution between a linear equation and a circle. Okay, now we're going to follow the same steps here, just so I can, so we can just see how this will makes sense. Okay, so essentially we'll have the same process. So right here, we need to isolate one of the variables. Okay, so we are going to go ahead and do that, and I'm going to go ahead and isolate this first one here. So we have first and second. So this is my step 1, and I'm going to use 2x plus y is equal to 1, and I'm going to isolate it by subtracting 2x on both sides, and we'll get y is equal to -2x plus 1. Okay, so I isolated one of my variables. Step 2 says to substitute isolated variable into the other equation, so we're going to go ahead and do that. So my whole, let's see, I'll write the original equation. So we have x squared plus y squared is equal to 10. Okay, well, since I know that y is equal to this expression, -2x plus 1, well, I'm going to substitute this expression every time I see y. So I'm just going to substitute it right here. So then we can say, let's say we have x squared plus, and I'm going to leave parentheses here, this y value, which is -2x plus 1. Right? So all this really means is we can go ahead and solve for x. And this is okay. It's just going to take a little bit more time for us to do this. So essentially, this is the same thing as -2x plus 1 times -2x plus 1 equals 10. Okay, I really want you all to expand this because sometimes this still confuses us, and this is where we kind of trip in our math. But we want to make sure you expand this into two binomials. And then right here, you can go ahead and do this on the side, some scratch work. And you can do box method here, -2x plus 1 and -2x plus 1. When you do that, you'll get 4x squared minus 2x minus 2x plus 1, and we'll get 4x squared minus 4x plus 1. So essentially, this right here will become what we input in for this new expression. So we have x squared plus our new trinomial is equal to 10. And then we can go ahead and combine any like terms. Well, I can see that x squared plus 4x squared will become 5x squared. And then we have a minus 4x plus 1, just bring these down, equals 10. Well, my goal is to find x, and I can't do that yet. So I need to go ahead and become a problem solver and subtract 10 on both sides. And we'll go ahead and get 5x squared minus 4x minus 9 equals 0. And you're like, okay, that's a lot of math, but okay, we're almost there. So right here, what we need to do is factor one more time, right? So we got to factor again. And this time, we would have to use reverse box method, essentially. So here, scratch work one more time. And I know my first term is 5x squared. My last term should be negative 9, and these two should combine to give me negative 4x. Now, there's many ways and many strategies to do this. We can say that, just as a refresher, that's where we multiply our leading coefficient times our constant, and we can do some side work there. And 5 times negative 9 is negative 45. And then we need to figure out what two numbers multiply to give us negative 45, but add to give us negative 4. And our only options are 9 times 5 or negative 9 times 5. Okay, and then we can go ahead and substitute those in here. So we have negative 9x plus 5x. And then we will get x plus 1 and then 5x minus 9. And so that becomes our new factored version of our trinomial. And then once we do that, final step, we'll do x plus 1 equals 0, and then 5x minus 9 equals 0, and we'll end up solving for x values, and we'll get x is equal to negative 1, and then x is equal to 9 over 5. Okay, and wow, that was a lot, right? So it says solve for variable. Well, we did that. This is step 3. It just took a little bit more time and steps. And then we still have to follow through and find the missing variable, in this case, our y value. So we can go ahead and solve for that. So step 4, we would substitute each of these into either one of the original equations. And I'm going to pick, let's say we'll pick the 2x plus y equals 1 equation. Okay, so we have 2x plus y equals 1. We're going to write that 2 times because we have 2 x values. Okay, and this is, we want to figure out what y is. So I'm actually going to use this equation where we already isolated y right here. So y equals negative 2x plus 1. Y equals negative 2x plus 1. Okay, so again, I'm going to use these solutions. So I have here when x is equal to negative 1 and when x is equal to 9/5, right? And we want to substitute that in. So we'll have y is equal to negative 2. There we go. And then we'll get y is equal negative 2 times negative 1, which is 2 plus 1, and you'll get 3. Okay. And then here, this will take a little bit more time because we have a fraction, but no problem. And we'll go ahead and substitute 9/5, and we'll multiply these out. So y equals negative 18 over 5 plus 1. So what we need to do there is rewrite this as a fraction and multiply bottom and top by a common denominator. So then y will equal negative 18 over 5 plus 5 over 5. We can go ahead and add the numerators together, and we'll get y is equal to negative 13 over 5. Okay, so essentially we have our new y values with their corresponding x values. So we have two solutions. So when x is negative 1, y is positive 3. And when x is 9/5, y is negative 13/5. Okay, so then we can say that we have two solutions for our circle and our linear function equation. So two solutions. Okay, so that was a lot of math and algebra. We will be doing this type of work in class, so get ready. It's pretty lengthy. It's going to look really awesome for you all to apply this. Right here, go ahead and write your summary. And any questions that you have, you can use your vocabulary words, but that's it, and we're done. Bye.